something's wrong, there are better ways. Sampling, as we saw in an earlier program, is one way to check on the process as it's happening. But as it turns out, it's only the beginning. Frito-Lay is one of the many American companies to add a new tool to their production line, Statistical Process Control, or SPC for short. It's a way for people directly involved in a process to know when to make changes and when not to. SPC is becoming universally accepted in American business, but it took a while to catch on.
I was a little fearful of the whole thing, not being totally familiar with statistics. It was something new to me, so there was a certain amount of reluctance on my part. But I soon became a believer once we started the process. Variability from bag to bag diminished. We've probably made a 50% improvement in variability since we've instituted SPC in our operation.
Statistical process control is made at critical control points in the process where you can actually impact the quality of the product. And by setting up statistical control charts or shoehorn charts, you can obtain signals that tell you when the process needs attention and when the process is best left alone.
Let's look at the production of ruffles to see how statistical process control works. Every 15 minutes, Karen Ingalls collects 3 batches of finished ruffles for salt analysis. Salt content is a delicate balance for Frito-Lay. It has to be great enough to achieve the desired flavor, but small enough to satisfy consumer health concerns. To check on the salting process, each batch of chips is ground up, weighed, dissolved in distilled water, and filtered into a beaker. The electronic salt analyzer gives a precise readout of the percentage of salt. This sample's salt content is 1.9%, just slightly greater than the target amount of 1.6. Karen repeats the process with the other 2 batches. The information is then collected by Barbara Boudreau for further analysis. Barbara averages the salt content of the 3 batches and comes up with a sample mean. She plots the mean on this control chart, a special kind of graph which lets her know when the salting process is out of control.
It makes sense?
Yes.
So what you need to really remember is that the guy said that you have to be careful at what point you set up SPC. Because it is a very strong tool you have in your hand. You can't put it all over the place because it will be very costly. Yes, you need to look at your cost also. So you need to be picking up the right spot, like where exactly you want to put the control. You saw her using the control chart, you saw her taking out the field. That's how they do it. It's not difficult at all. I'm going to show you. So this is a different kind of operation. I'm going to show you with the lens of a different kind of operation. Short video. Things will become just clear.
In manufacturing, measuring the results of each process is vital to the success of the company. At ABBA of America, they rely on statistical process control to continually monitor and improve their processes.
Statistical process control is simply monitoring the consistency and the repeatability of a specific process. It's not a complicated thing. It's really quite a simple approach to understanding what is the reliability of my process. An example of that might be torquing a bolt. In torquing a bolt, there are a lot of variables that can go wrong that cause an over-torque or an under-torque situation. In that example, if we apply statistics and understand the actual capability of the process, we can predict the failure rate within that process and make running adjustments so that we don't have actual problems occur. the data is consistent and stable. There is no assignable causes present, only common cause variation. In addition to the SPC charts, we also use a histogram in order to do a process capability on this particular characteristic. The histogram shows a distribution of the data based on about the last 2 weeks of data. The CPK is a capability index that tells us how well we are at meeting our specifications. Industry standard shoots for a CPK of 1.33, and we are currently meeting that. We have a number of different ways that we collect data when we're doing statistical process control and monitoring. Those range from equipment that automatically collects the data to a manual process where the associate's actually taking the reading and plotting it manually on a chart, to a process where we may be doing some offline inspection and actually collecting data with some hand gauges. This data is processed in a number of different ways, but the most effective method is by the associate understanding what do they do when they're out of control, when they find a point or a measurement that is not where it's supposed to be, and then they take action on it on an ongoing basis. Waiting and analyzing the result after is not always that effective, but for continuous improvement, doing it as you go is what's important.
During the door closing speed test, a result came back that extended outside the upper control limit on the control chart. This indicated that for one door on one certain car, it took an unusually high amount of speed to close the door without slamming it.
This is an individual's chart, or an X chart, showing a plot of data of door closing speeds over a certain period of time. On the chart, you'll notice an out-of-control condition at this point, meaning there is an assignable cause potentially present. This assignable cause was investigated, and it was found to be a problem with the fixture used to install the striker. The striker was installed slightly offset due to a broken fixture. When the striker is slightly offset, it will cause the door closing speed to be higher than normal. The fixture was replaced, and the data fell back into control, and it was consistent and predictable once again.
By teaching their employees to understand statistical process controls and how to immediately counteract out-of-control situations, Honda prevents problems from recurring during manufacturing and is able to maintain an outstanding level of quality control.
Becomes clear? Yes. So what he said, he spoke about continuous improvement. Continuous improvement would mean that if Honda waits like when all the cars are ready and then try to find out what is the reason, it would be too late because the cars are already manufactured and gone to the plant. This is sometimes you hear in news that a company recalled 1,000 cars or 2,000 cars. That's why they have to recall, because they haven't used these charts on their tank. Like that person used control chart. So he knew that one of the doors is not locking off properly. So he just went to that car instead of going all over the place. Let's fix the problem. And that is what it is. Going back to the slides. So this was our process control for the lecture. When you go home, you're going to go through, or maybe you have already gone through it. But if you haven't, go through it and see if you understand it or not. If you understand it, that means that whatever we have done so far makes sense. If you don't understand that, and try to understand it. Okay? Okay. What is really happening? What is really happening? Is clear? Yeah. See? They are not stranger to you anymore. All she's doing is looking at this and then plotting it, like in one of the videos. Just doing it with hand. Jamaica Brothers does that, doing it with hands. Some big companies maybe would just use their system and just throw in the numbers. And as the guy said, there are different ways to collect the data. different ways. Alright. So we have done the variables, then type those variables. Now we are doing attributes, like I gave example. Tube light, good tube light, bad tube light, attribute. So if it is good, it is acceptable. If it is not good, it's not acceptable. As simple as that. Counting defectives, counting one by one. This tube light, good, check it. Connected with some plug, check it. Or it is sometimes done automatic systems. Some way to make sure that the light is working. Charts, so okay. We have done two types of charts. Excel chart and both needs to be seen. Now, each chart is looking at percentage. 20% of the lot is okay. 30% of the lot is okay. 10% of the lot is okay. But the other one is looking at the specific number. 1 tube light is okay. 2, 3, 4. Yes? But we chart now. Same thing we're going to do. We're going to solve a question, but before that, two formulas, just like X bar. Yes. This should be familiar from statistics class. But still, look at this. Still following central. The next one will be Poisson distribution, but we still would look at central limit theorem. As I said, central limit theorem is the fundamental, the grounding of this stuff. Okay, so this is the question here. 99.73. Yes? We're going to pick up what we are going to do here is that we are people who are doing something for us. 20 people. 1, 2, 3, 4, 5, 6, 7. Maybe there are a lot, but we have taken out a sample of 20. And from all of this we have counted the number of errors. Like this person out of 100 has made 6 many errors. How we know it's out of 100? Because this one is saying 0.06, so yes. But you need to calculate that. What you are doing is you are getting the record, checking the record of every person. You're going to person 1, that person has made 100 entries. You're going through all the 100 entries and you found out that person made 6 mistakes. So you put 6. And you go to the next person. You go through the 100 entries and you find out 5. So on and so forth. This is what you are doing. At the end of the day, you found that there were 80 mistakes. But the total sample size is these 20 people times 100, because you collected 100 from everyone. If you collected 200 from everyone, you put 200 here. If you collected from 30 people, you put 30 here. If their errors you found out to be 100 here, you put 100 here. Just the formula. And you plug it in this, and you get your standard deviation. Same thing. No big deal for you guys now. Control chart. Yes? Familiar with control charts? Alright. So you're just plugging in same way. Like I showed you one of the previous examples. Picking up the data from here. 1 is going in the table. You plug in for 1. Yes? Can see it? Can see it? Alright. So 2, 3, 4. Why do you want to do it? see any abnormality in this? Right. We're just gonna check what's happening here. Just take care of the problem. Possible. Look at the term possible. Should appreciate that possibility. Don't jump to the conclusion that no man, this is wrong. No. Take your time. Try to understand. Look at the picture in totality and then make your move. See chart? Same thing. But this time it's poison. But again, standard limit. Good. So at the base it is standard limit. And you have another question now? Same thing you're going to do. You're going to set the process in control. What should be the upper control limit? What should be the lower control limit? That's what you are doing. But over here, the guy has said that control it 99.70 to 99.70. What does that mean? That means 99.70% of the data at the end of the day of the production will be within the limits, stats class. Yes? A little mistake here if you want to correct it on your. Yes? And you just plug in the numbers. Plug in. And you know, this is, if it is within this, it's okay. If it is out, same principles you use in the text. But now, what you need to know is that where to use which chart. In the exam, you would not be told use X bar chart. You would not be told use R chart. You know these things. Which chart you use now? Simple, no problem. If you want to find out how closely it is to the mean, you need to use X bar chart. If you want to know the dispersion, R chart. If you want to know what is the percentage of the difference, if you want to know the exact numbers, beautiful. Alright, now we move it ahead. Basically we are covered with charts, but we are looking at different picture now. Like as a manager as I started.
Dispersion for R?
Yes.
Range.
And like, don't write it. If you are writing it, you are missing the point. You should just don't write it. It should be like this, that you don't have to revise this question from now on. Just go and exam and just write it down. This is the first question you should be attempting. Okay? Why not? Give it a try. First question. Just done with the first question in 20-30 minutes and you have all the time to do the rest of the questions. Yes? Alright, so as a manager now, operations manager, you need to make sure about a couple of things, and that's what basically we have covered this, but just select points in the process that need SPS. As I said, that if you try to use it at every point of the production, no, you have to make you have to make up your mind where to. You have to make up your mind where to really use it. At which point you want to use it. Which point you want to use X bar. Which point you want to use R. Where C chart is not helpful. And a lot of other charts. If you can visit your statistics notes from that class, you would see there are a couple of different charts. All those charts are to be used here because they are, in a way, they are controlling something. Yes? So select the point. Determine the appropriate charting technique, which chart to use. So if you are asked this question, 3 major management decisions this like granite. Yes, at that time, you just think about it. Put yourself in the shoes of operation manager and see what are the things, you would want to list. And if it is not there, but based on your experience, you think this is what I would want to look at based on other examples like the plane landing example, the cricket example, the hotel example. You can come up with another thing. That is, select clear policies and procedures, clear cut. Your staff must know that if one thing, the person who is operating the machines, he would be the first one to look at this outline. Right? He must know what to do at that point. Should he just stop the line right away? Should he just let it run? Should he look for if there is any other outline? Not just this. Watch this now. Watch this. One point is this. One point is this. One point is this. One point is this. Then stats class, forecasting, trends. That chapter. This is within the limits, guys. It's showing a trend. It might go here. It's showing a projection. So a smart employee, he's not going to wait once this thing comes in. It's not efficient. Not doing his just, not doing his job properly. Let's look at trend also. If something is too close, why is it too close? But all of this depending on what is the production line which is running. Is it, are you in charge of traffic control at airport? This is a no-no. Even if, as he is landing, even if he tells that I'm going to land here, which they do, that this is our projected path where we land, you are in that room, that little room, no, don't land, go up back, come back again, and land up. Yes! You can't land here. Especially if it is raining. And him saying want to land here. What are you going to do from that? And look at the importance of understanding this thing, guys. You are in that room, and if you are looking at this chart, and if you let that aeroplane land here, how many people will die? How many families? That's how the accident happens. Have you ever thought why the accident happened? That the person, the pilot doesn't know where he's going to land? He knows. He knows he's landing. See, he's landing. He knows he's going to land here. Why? How can an aeroplane skid like that? Just like that. I'm not saying it can't, but I'm saying just take some precautions. Make it land here. So this is the significance of what you are going through here. It's not anything which you can say, oh, never mind. It's not of any use for me. I just need to remember it for the exams. No. If you want to run your own business also, for example, you would have an operations manager. That person is doing these things. So if he shows you just X chart and says everything is alright, bring the R chart. Yes? Alright. So this is saying the same thing. Where to use which chart? Just a little technical piece. But basic, that's the concept. This is next chart, next one will be saying actually each chart. Pass or fail, good or bad, the same as pass or fail. Just changing a few words. Fraction, proportion, as we saw in that example, 0.06. Attribute C chart, this time we are counting. 1, 2, Once you have to count, C chart. Once it is percentage, E chart. Once you want to know how close it is to the mean, X bar chart. Once you want to know how dispersed is your alright. Kind of covered this already. Look at this now. And suggest as an operation manager, when you see this, what you will do? No tricks. Same commands. But if you are at the airport, what will you do? So depending on the context. So if in the exam situation you are given a chart and you are said what you are going to do, you start with the context. And then you explain why you need to give different examples. Some examples where this is not good. But a lot of examples where this variation is alright. Also, don't just look at this. Guys, look at this. Maybe this is very close, like 5.555, 5.556, 5.557. Maybe in which situation it would be that close? Why Cinco uses it like this, and they are producing straws. Straw has a length, right? But every straw is not of same length. You can check it. But you have to check it from different production line. Buy one straw from Pavine, buy one straw from Constant Spring, buy one straw from Negro, buy one straw from... Collect data and then place it. Different days, different months, because you want to select from different batches. And then use some tool, not eyes, because eyes gonna say, a little variation. Very little. It's possible. But if there is no variation, that means the plant Cinco is using the highest standard possible. I'm not saying there will be a variation. Maybe you find and you do the test and you say, that was foolishness. Same size. But that is just saying that Cinco is using a very sophisticated stuff. So, this is this. Next one, obvious. You can deal with that. Yes? Alright. Yes. Have you done this? Yes. Yes. Who said no? Who said no? Okay. You could say no. Okay. Investigate. We are in line. Nothing to worry about. For now. For now. So if you wait till the time when it is gone there. Yes. So if you wait. Hold on. If you wait in here, you might face other problems also. For example, as an angular client, I have ordered 100,000 straws. If you don't look at this problem here and deal with it and bring it in here, and you reach here, you might have to stop the process, you might have to order a new machine. That would take time. And my demand would not be fulfilled on time. You need it on time. I don't know what the problem you have. I'm paying you. Should have. So when you are running at the plant as operations manager, those are the things that you are looking at in your room. You are not in the plant. Think about those things. Okay. This is what I need to produce in this first time. Yes, what is it?
So what stood out to me is the gap between the two lines.
Which line?
No, one where no, right above and one below. Yeah, the space, right?
This is just an example. This is just an example. It's just saying that your finger is just going up. You need to see what's happening. The next one is another example. It's going down. Or maybe is one. It can be one. Just put one down this and this. Straight across, yes. This is just to make you appreciate that this you are seeing something which is within. Still, you need to look at something. Alright. There might be some production line where you don't want them to do like this. Many reasons can think of. Yes, no problem, no problem. Take this. If we get time in class, we will read it in class, but seems like it is homework kind of thing. Yes? Alright, no problem. Okay. Alright. So, the operation manager from his room, he said to the staff, if you get 5, 1, 2, 3, 4, 5 like this, even though there are interlimits, let me know right away. Yes? So this is what are the instructions from the company, from my single, the chairman, whoever the chairman. He said, whenever 5 up or down, report to XYZ. Maybe not operation manager. Operation manager is doing a lot of someone else, maybe his personal assistant. He can make some calls and make some people come and they look at the machine. Why it's not like this? This close. Why we are doing this? We want to be close to the target. This is the target. This is the target. And we want to be on this line every time. Every time. Every time. Every time. But it's not possible maybe. So here is a trick. When I say it's not possible, that's wrong. Now the human beings have gone to the moon. Why is not possible to put it on? It is possible. But what I mean is that it's very costly. You have to spend a lot on the machinery. Every part should be like a Ferrari. Why a Ferrari is Ferrari? Because every part, they are taking care of every part. Every part. Every part. So this is wrong. That is not possible. It's wrong. It's possible. But why Simco cannot afford to spend so much? And furthermore, they say, this is our target, but our clientele, if this is like this, they accept it. They accept it. You go to a restaurant, you order some food, they bring in some food. You like it. You go there again, you like it, but it's a little different. You say, okay, no problem. But other things are very good. The service is very good. The ambience is very good. All those things are very good. A little difference in food. And with that, the manager comes in out himself and he say, we had a little salt. We forgot to put a little salt this time. So I'm sorry. And whatever. So you say, alright, looking at totality, you say, no problem. A little different. But next time you go and you just make out with something else, you're not going to like it. You would say, I don't want to go in that direction. So the manager also understands that in the dish where he need to put 0.005 gram of salt, if chef puts 0.007 gram of salt, it's okay. Whenever you you buy from KFC, the taste is not 100% same.
No, true.
But-
Think so.
But
Okay.
they make it very close. If it is a good, it depends on the person who is running that branch. You can't say in KFC because they have send a clear directions. Heating time of the potatoes, the
Oil.
everything to the T,
Yeah.
to the T,
Yeah.
to a T.
Yes.
Like this much, you need to put 0.05% gram of oil, whatever it is, whatever. Exactly.
No, it's done at each location. It's done individually, what they.
Next, look at this.
Yes.
Look at this.
Okay.
This one is now same. The process is all about this.
Type of cooker.
It is not in control at all. It's sometimes going up, sometimes go down, sometimes go up, down, up, down, up, down.
Different.
Random.
If you change.
You don't want random process. You want it to be closer to this. But look at this. Go down, go up, go, all over the place. So you would want to check. Why is all over the place? Yes? Capability now. You want to test the capability of the process. Is the process capable of delivering? What this slide is really saying that this is the spec limit, lower spec limit. This is upper spec limit. Specification of client. This is what, like in a previous slide on which we never spent a lot of time, was talking about a histogram. You remember? Yes. That is what he is talking about here. So this is the production, and this is in between the spec lines. So if it is in between the spec lines, means the process is capable of producing whatever is required. It's capable. But if the customer wants this, this is what the customer wants. This is what the customer wants. And you give this. There's a little problem now.
Yeah.
As a customer, I'm getting this. But this time I want this. So what is happening here? I'm getting this also. I'm getting this also. I'm getting all of this, which I want. But I'm also getting this. Do I want that? I don't want that. Should I pay for that?
No.
This is how you check. And then there are some fancy capability B, capability E. That's your ratios. But this is what is the principle. Alright, CP. Formula. At least one. This is what you might want to remember. At least one, whatever answer you get for CP or CPK should be at least one. As long as it is one, that means that is what that means. Alright. Let me make a diagram to make it clear. CP1 means, what is this? Spec limit, lower. What is this? Spec limit. A CP would be equal to one of this diagram. Why? Because it's just touching spec limit. So it's one. And this is at least what you would want. But you would want a better CP. As the CP becomes better, what is going to happen? Look at this now, please. What is going to happen is the plant is going to produce the products which are closer to the target value, to the mean. So as it comes closer, the CP would come. That's all. If now the picture is going here, that what does that mean? What is the value of CP? If CP value is 1 over here and it is increasing over here, what is the CP value of here? Not negative as yet because we are at 1. So
Oh, okay.
we're not gonna go
Yes.
all the way
Yeah,
negative.
yes.
Take your time. Go to 0.90, 80.
Yeah.
Yes. And target value, sometimes they are saying 1.33 is used because this would be a little in within the spec limit. Yes, that is what it is. So CP2, you have done quality in this course?
Yeah.
Yes. So you must have done sigma, 6 sigma, 3 sigma.
Yes.
Yes. Alright. Moving on. 6 sigma. Yes. 2. Yes. Remember that class? Start getting it. Divide. Alright. This is the question now. Same thing. Alright. So, design specification 210 plus minus 3. 47. And you just put in these numbers, x bar, s, everything is given in the question. All you need to know is find out what is the formula you're going to use. This is the formula for CP. 210 plus minus 3, 210 plus 3 is what? And what is it? The other one is what? Alright, we have lower upper. This is upper, this is lower. What are you going to put here? 230. What are you going to put here?
207.
What are you going to put here? Standard deviation. 6.
Standard.
Is it hard?
No.
Alright. Now, very important class. When you get this question in exam, which I think you should get. But I don't know. If I make the paper, I would put this on. Okay. And what I would ask you is that I would not be interested in this, to be very, very frank. Even if you write, like it should be 213, if you write 215, if I'm checking, I won't cut any mark, to be very frank. I don't care about that. You put 2, as long as you don't put like 500 there. If you put, I won't even look at that. I won't even look at how you calculate it. I will come to this and see what is your understanding of this. What does this mean? If you explain to me, if I got your lecture, I'm not, but I'm just trying to give you an understanding that how important the number is, because as operation manager, you won't be getting all of this. You will be getting this. That's it. And you make your move. Yes. This now. You should know this already because I explained it over here. What does this mean? 1.9. Yes. It means that but any ordinary student would write that. That is not wrong. That is not what I expect from you, especially with what I went through. I don't want, I would be really like sad that if you just write that it's capable. Even though it's right, you get your marks, but I really disappoint. You need to write that this process is, anyone can make up what I want to say. No. Okay, no problem. Now you know. You remember 6 sigma and that, those things I think you are forgetting.
Yes, that is what
No problem. You're right, but that is not what I'm referring to. You're going to say that this process is super capable. Super? Super. Like super or very capable. Very capable. If you don't write super, I'm not looking for super. I'm looking for any word which is saying that it is highly capable. Yes, because Six Sigma is true, as you remember from college. Six Sigma is a big thing to achieve. There are quality standards, ISO, and those things which are covered in, must have been covered in that class. So, very capable. Why? Because it's very close to 2. A process is capable as long as the value is 1. As the value of 1 increases, it becomes more and more and more and more capable. More capable. Yes. So see, it says process is capable, which you saw in your slides. Yes, exactly. But it is a very sophisticated process. If Bicinco is using this process for straw manufacturing, then the chances are very little that you will find a lot of variation in the straws and the samples which you would collect. Different formula. At least one. As I said earlier, CP or CP level at least. See if it is 1. As long as it is 1, it's alright. But if you want to improve your businesses, so a question, all the numbers are given. Yes, plug in. I think it is a mistake as I was putting. I think it should have been plus minus. As I read, I think it can't be equal to 1. Where is the equal sign? Yes, see, equal sign and plus sign are on the same tab. So, plus, minus, same kind of process. Grab these. And you just plugging in the numbers. And plugging in the numbers. And you get this answer. So all this that calculation, a CSC student can do that calculation. That's not a problem. What maybe he can't do, he can't understand. What is this? Now make me understand. This says new machine is not capable, which is this. And why it is not capable? Because the machine which is already running has a CPK of 1. If this question is just changed like this, 0.1, 0.1, what will you do? Would you accept the new machine now, or still you would say it's not capable? I am changing the number. I am making a change in the question. I am making a change in the question. It is not this now. I am saying it is 0.1. You will accept the new machine. Who in the class will not accept the new machine? Is there anyone in class who will not accept the new machine? So just don't stop at calculation in the exam for any question. Never stop at the question. You need to write after that. That is where you get the marks. Explain. What does this mean? Give some examples. Yes. Like the mathematical part is just like this. But you can explain, like take maybe 10 lines. If you really understand the concept, maybe 10 lines, explain it. So the person who is checking your paper, he really knows that you really understand this thing inside out. So if on some other question you make a mistake and you are kind of maybe failing, he would say, no man, this person knows a lot about at least these things. So if you are getting 49 out of 100, for example, that's not going to happen with you. But I'm saying you get 49 and you show that kind of understanding and appreciation in your exam paper. For the other questions, the lecturer would be insane to fail you. He must give you one more mark. Come on, one more.
Sir?
At least.
A question. I see how point this sigma is 0.005 inches there.
Yes.
Question 6.001 of an inch.
Sorry?
The question?
Where is the question?
Yes.
6.
0.001.
No. Look at this. Anyone can explain in class, please? You must know this.
Standard deviation.
Must know. No problem. Standard deviation is given. And the 0.001 you are referring to is plus or minus. So you are plus or minus this mean. So this is one added here, one decreased here.
Yeah.
Standard deviation. Yes? You must revise, you know. If you don't revise, time waste. Totally waste. Before you sleep, go through it one time. And I promise you, you won't have to go back to it. Yes. You might have to just a day before exam. Your exam is like in 3 weeks. 27th or 28th July. This month. You might have to revise it, but now it's very fresh. If you revise it, you are sure that if you are sure if he gives you a question from this, you should be able to. But ask him if he's going to give you a question from this or not. Or do you want a question from this paper or not? You will say it. Alright. Interpretation now. Very important. Very important. You cannot interpret. You cannot interpret. Okay? Alright. So this, I have explained you here, that in the limits, as it touches the limit, it means it's 1. Remember?
Yes.
So this is okay. As it increases, it is shrinking. Remember?
Yes.
Alright. What does this mean now? No, that's the small child stuff. What does that mean now?
You have more control over the process.
My God! My God!
Yes.
That's what I wanted. Beautiful. Very right class, man. Huh? Alright. So what is happening here?
It's going to variation of
So what are you going to do?
Investigate, find it's correct.
So if he shows you this and asks you what to do, don't panic at all. Like sometimes when in a maths kind of setting or stat kind of or economics or finance, they ask you what to do now. And you say, well, I don't know what to do. I don't know what's happening. How I am supposed to know what to do. Just remember this. All you need to do is in this diagram, make sure that you remember this. Everything will follow. If you can remember that this is 1 and CP is also 1. Remember?
Yes.
No. Both of them should be at least 1. Yes. So why no one corrected me? Alright. So this is basically saying, okay, look at They are not outperforming their job. They are not out. Don't write it. Why are you writing it?
Yes, ma'am.
Okay?
We have for ourselves on the
Alright. Oh,
like it's funny.
alright. If it has. But all it is saying that they are producing on the minimum standard, which they are not doing anything extra. So if they are producing on this level and they say, okay, initially Bicycle tells me to pay for 100,000 stars, they ask me to pay 500, for example. And then with this kind of performance, they say, okay, Rashi, give me 550. What I'm going to do? But if they give me this, what I'm going to do? Or expand your horizon. Or if they produce on this, I would say, oh man, don't be too smart. Don't be too smart. You don't need to overdo it. Because I'm not going to pay you anything extra. Yes. You can go on and produce on this. You can. I don't mind. But I'm not going 500. And if you go below this, I'm going to pay it as. That's where the business is going. Can he afford that? No. Can't afford that. So he would say, alright, make sure that it is. But it's good for my Cinco that they produce on this, because when I need plates, where I would go? Where I need cups, where I would go? And then this is self-explanatory. Yes, makes sense? Accepting. Alright, so now we are going to something else. We are saying that instead of using statistics and all those things, we are just going to inspect the individual items. We're going to inspect. Look at hold one item, see what is the situation here. Leave it. Next item, hold. Next item. All the items. Why we are doing that? When I get the shipment from my Cinco, I want to make sure that it is within that range. I can't just trust them that okay, CP is equal to 1. Take the stuff. No, my people are there. When the truck comes in, they unload it. Same time, I have a person who is going to randomly pick up a box, open it, take some straws. Next truck comes in, do the same thing, pick up some straws. The unloading process will not stop. I will not stop that. That is happening. I'm not trying to, stop their shipment. No. But at the same time, I'm just doing my check. And all the samples are numbered. Truck 1, truck 2, truck 3. That's what happens like the Jamaica brother is sending out their chicken or whoever is, wherever they are sending that supermarket, there is someone who is doing this. Now it is up to those people what process they want to use. And we are saying in our class that SPC, what is the name? Statistical Process Control. Yes. This is one of the sophisticated ways which we can use, and we have seen the chips example. They are using it. One of the best chips in the world. Yes? Yes. And then we saw example from one of the best cars in the world, Honda. Their reputable name. They are using it. So you have learned a very strong tool. Now you must use it wherever you are working. You use it. If you are a manager, you can use it. If you tell your manager about this, give a short presentation. Give a short presentation to your colleagues, to your son or daughter. Go home and show the video. let's see what his horizon is like. Maybe he's doing like CIC, math, stats, whatever. Showing this
Sir, how will you supply in the services industry?
service, yes, service industry. The example of hotel.
Banking.
Different ways.
Matrix.
Sorry?
The use of matrix,
What is matrix?
the volumes and variations in
Anything that just the concept is underlying concept is that whatever you are doing, you need to make sure that the quality is within the bound. Now you can use in a bank or whatever. Like if you ask me how it's going to be used, I can give you examples, but well, maybe they are not using it. You can say maybe they are not. Like for example, you ask what you make up example.
JUTs.
Make up example like the countries in huge debts. They keep on borrowing. There is no upper limit. No one.
JPS. How do you have that at the JPS?
You can't like the GPS.
Is it evidence?
Sorry. So what it is doing, come back to the slide, let's come back. Take samples at random. Inspect each sample, decide whether to reject or accept. Like this standard is on the delivery when you are getting your stuff. Okay, so if I ask you if the lot comes in by Cinco is sending the straw, that I say no man, I don't want it, take it back. What is the loss of our Cinco? They will be returned to the supplier. Simple. Now what is the consequence of that? So whoever is in charge of straws at Bicycle, big time trouble, and then move the job. And to the next job where he goes. So SPC, please guys, SPC, Statistical Process Control, is that important, that critical. That is the significance of this, what you are learning. Yes? Alright. So now it's just saying that whatever from the economics class, this is the max. Yes? Whatever is in this, okay? Whatever is out. Yes? Simple. So you're going to make a sampling plan. I think it is. Yes? Simple. Very simple. So what it is saying, this is the percentage of defects. When my people see the shipment arrive by Cinco straws, I'm going to tell them, as long, there will be defects, 100%, as we have established that, it cannot be 100% for by Cinco maybe, or maybe in Jamaican context, unfortunately. Unlike first world countries like who are the people who make rockets, the parts they put in that there can be defects, because if you put a defective part, even if that means if it is 10% defective, it means it's a 10, the probability that the rocket will go out of start is 10%, which is huge.